All right, so Class D fires. Class D fires involve combustible metals such as magnesium and sodium. Combustible metals fires are unique industrial hazards which require special dry powder agents. So, for example, a metal fire would be a car on, excuse me, a car on fire. Usually, when you apply water to a car on fire, it makes it gets really cool too fast, and it starts like popping and sparking up. So that's very important when being safe extinguishing a metal fire. So to prevent Class D fires, we want to know the properties of the metals, and using good judgment and common sense will assist you in controlling and avoiding potential fires. Class D fires are represented by a yellow star, so that's very important. Like I said earlier, for example, this is a car on fire. Notice how he's putting the agent on there and sparking it up like fireworks almost, and that's because the magnesium is cooling rapidly. And this is what happens. And finally, we have Class K. Class K fires involve combustible cooking media such as oils and grease commonly found in the commercial kitchens. Class K fires, you're cooking bacon on the stove, and you're experienced, and the oil gets over on the flame, and then next thing you know, you have a fire. So you gotta be careful when doing stuff like that. Class K fire. This is what represents Class K fires. Um, for this is an example of a Class K fire. As you can see, the pan is on fire on the stove, and once it gets going, it reaches the cabinets and it starts burning the cabinets all the way to the ceiling. So it's very important not to put water on these types of fires, because as you may know, gas and not gas but water and oil don't really mix together. So therefore, it's gonna make even more big fire. A lot of people don't know that. A lot of people because a lot of people don't know that, they result in a lot of damage on the house. So therefore, people need to know what types of extinguishers to use on these types of fires. So section two. Section two, we're going to talk about heat transfer. So heat transfer. Heat transfer is the exchange of thermal energy between physical systems. The three fundamental modes of heat transfer are common are conduction, convection, and radiation. So conduction. Conduction is the transfer of heat between substances that are in direct contact with each other. Metal is a good conductor of heat. I remember I used to always grab pots and pans off the stove, or cast iron skillets off the stove, thinking that it wasn't hot, but conduction heated the whole pan up. It kept traveling to the cool side of the pan until there was nowhere else to go. So therefore, when I reached to grab it, it burned my hand. That's an example of conduction. Conduction occurs when a substance is heated. Particles will gain more energy and vibrate more. These molecules then bump into nearby particles and transfer some of their energy to them. Energy conduction. This is a diagram of conduction, like I said earlier, the pan example. Um, Touching a hot pan like that, it will burn your hand because conduction heats up the whole pan. So if it heats up this part of the pan, it's going to keep going until it's going to keep going all the way until there's nowhere else to go. And so therefore, if you touch that pan while it's been on the stove for a while, it will burn you. So next we have convection. Convection is the energy. Thermal energy is transferred from hot places to cold places by convection. Convection occurs when warmer areas of liquid or gas rise to cooler areas of liquid or gas. So that's like bubbling water. If you put your hand over bubbling water, you're going to feel the heat. That's an example of convection. Water boiling in the pan is a good example of these convection currents. Another good example of convection is the atmosphere. So as you can see in this diagram right here, the reason why water boils is because it's rapidly going in circles. The the hot the hot the hot water or the hot gases keep going to the surface, and it's like the cycle, and that's what makes water boil. So radiation. Radiation is a method of heat transfer that does not rely upon any contact between the heat source and the heated object, as in case with conduction and convection. So, for example, radiation would be I know I used to always look at the road and see like the waves. It looked wavy, it looked like it was moving because it was so hot. That is an example of radiation, heat. Heat can be transmitted through empty spaces by thermal radiation, often called infrared radiation. So we do receive the sunlight we receive or the heat we receive. That is an example of radiation heat transfer. So, for example, this diagram shows a campfire, and you warm yourself around it using the radiant heat that's coming from the fire. The energy that's coming from the fire heats you up. So next we have smoke. So what is smoke? Smoke is the collection of tiny solid, liquid, and gas particles. Although smoke can contain hundreds of different chemical fumes, visible smoke is most likely carbon, tar, oils, or ash. Alright, so I'm going to start off with wet smoke. Wet smoke. What is wet smoke? Wet smoke is smoke is created in a slow, low temperature fire. Wet smoke, because it can create thick, sticky film and residue that can build up on surfaces, causing damage and emitting heavy smoke odors. For example, if you have if it's raining outside and you light some leaves on fire, they're really, really damp and moist. They won't burn as if they were dry, but still they're really damp, and the smoke will be a lot clearer rather than if they were really, really dry. This type of smoke buildup is also the most difficult to clean and remove from belongings and structures. So that's very important when we're talking about property conservation. That's that's one of the three main goals of the fire department. Is property conservation. So that's very important when trying to conserve people's property. So like I said earlier, this is an example of wet smoke. As you can see, the leaves are really damp and the smoke is like clear-ish. So that's very important when I'm talking about smoke. Dry smoke. So what is dry smoke? Dry smoke is when fire reaches high temperatures. Dry smoke has a fine powder-like consistency that is due to the form. It can easily be cleaned up from solids or surfaces. So if you were to burn something dry, it would burn up instantly. It would burn up faster, and it would burn up so fast that it wouldn't leave that much of a mess. So therefore, you can clean it up really easily. The only time you must be concerned about dry smoke is when the powdery-like substance becomes trapped in cracks and porous surfaces. When it can find and emit musky smoke odors and become highly difficult to remove. So this is an example of dry smoke. This is a grassland on fire. So that's very important when talking about containing fire and stuff like that. Protein smoke. Protein smoke is when food or other organic materials are burned. It can create protein smoke. This type of smoke can create soot that is very hard to see but easily to feel. It's generally light in color but can be permanently discolored with wood surfaces, and the odors it emits can be overwhelming. So, for example, if you're burning burgers or something, you're cooking and you're burning it, you're gonna feel that that burnt smell. That smoke is gonna be really, really strong. So that's an example of that. So as this example right here, this gentleman burnt his burger, so therefore he smelled that burnt smoke. So therefore, that's very important. Petroleum smoke. Petroleum smoke is when oils or oil-based substances are burned. Petroleum smoke is then produced. This type of smoke is dark in appearances and will discolor and stain any material it touches. Fortunately, due to being oil-based, this type of smoke may be able to be cleaned with the degreasing agent. So that's very important. So this is an example of petroleum smoke. He has oil on the stove on fire. As you can see, the smoke is a little bit thicker and it's flaming by the fumes. So that's very important. I'm talking about conserving property. Section 3.